Orientation of aromatic dye substitution in benzene. In the electrophilic substitutions, benzene formerly one mono-substituted product. For example, in the mono-substitution with electrophiles, benzene mainly from mono-substituted benzene. Here, the six carbons of benzene are same. That's why the substitution is mono-substituted benzene. If a further substitution reaction is carried out on a mono-substituted benzene, here only the five positions are available. These five positions are different from each other. These are again classified into three types. One is ortho position and meta position, then para position. 1 comma 2, 1 comma 2 and 1 comma 6 positions are called ortho positions. 1 comma 2, 1 comma 6 positions are ortho positions. 1 comma 3 and 1 comma 5 positions are meta positions. 1 comma 4 position is para position. The first substituent at first position. If the second substituent at second position, that is called ortho position. Second are 6. These two positions are called ortho positions. And 1 comma 3 and 1 comma positions are called meta positions. 1 comma 4 is a para position. The substituent which is already present in the benzene ring will direct the incoming electrophile to occupy a particular position of the benzene ring, and it is also affect the rate of the reaction. This is called orientation. Orientation means already present a substituent on benzene ring. This substituent will direct the entering electrophile to occupy a particular position. For example, if it is a ortho or para or meta, and it also the affect the rate of reaction is called orientation. One group attached to the benzene ring affect the reactivity of the ring, and it determines the orientation of further substituents. For example, a group, for example, a group causes attacks to occur mainly at ortho and para positions. Mainly at ortho and para positions. It is called ortho para directing groups. Ortho para directing ortho para directing group. Whereas a group that causes attacks to occur mainly at position meta, to it is called as meta directing group. Meta directing group. For example, Ortho para directing groups, example OH group, NH2 and NH or OR, SH, CH3, X, CH2OH, CH2Cl. These are the examples of ortho para directing groups. Some examples of meta directing groups, that is NO2, N, NC, SO3H, CHO, COR, COOH, carboxylic acids, esters, amines. Those are all meta directing groups. For example, ortho para directing groups and meta directing groups. Ortho para directing, for example, here, for example, benzene, benzene ring is having a one substituent, one group or one substituent, a group that makes the benzene ring more reactive than benzene ring is called activating group. Activating group. A group that makes the benzene ring less reactive, less reactive than benzene ring is called a deactivating group. Deactivating group. Here, a group that attached to benzene ring, it increases if the group is a electron releasing group. If that group is a electron releasing group, electron releasing group donates electrons towards benzene ring and it increase the electron density on benzene ring and it increase the rate of increase the active, and it is increasing activity of benzene ring. That's electron releasing groups increases the electron density on benzene ring. These groups are called activating groups. These are ring activating groups are ortho and para directing groups. Ortho and para directors. For example, if the group is electron withdrawing group on benzene ring, these electron withdrawing groups withdraw electrons from benzene ring and it decreases the activity or decreases the electron density on benzene ring. These type of groups are called ring deactivating groups. The rate of reaction is decreases and the ring deactivating groups are meta directing groups. Meta directing groups. For example, I am telling the substituents that activate the benzene ring by increasing the electron density and direct the incoming group to ortho and para positions. The substituents that deactivate benzene ring by decreasing the electron density and direct the incoming group to meta position. This is the orientation. For example, if electron donating groups or electron withdrawing groups. For example, electron donors, or electron donating groups on benzene ring. These electron donating groups donate electrons towards benzene and increases the electron density on benzene ring. If electron donors are present or electron releasing groups on benzene ring, these electron releasing groups increases the electron density and electron density on at ortho and para positions. That's why the entering electrophile attacks at ortho and para positions. Means here electron donating groups or activating activating groups or electron donating groups are ortho and para directing groups. If the electron withdrawing group on benzene ring, if electron withdrawing group on benzene ring, these electron withdrawing groups withdraw electrons from benzene ring, then what? Here the electron density decreases on benzene ring. Here electron withdrawing groups on benzene ring, the electron density on ortho and para positions are decreases. When comparing with meta position, ortho and para positions are less electron density places. That's why the second electrophile enters into the meta position. Meta position. Here we can say elect ring deactivating ring deactivating groups or electron withdrawing groups or meta directing groups. Ring deactivating groups or electron withdrawing groups or meta directing groups. For example, for example, I'm taking one example. NH2 aniline. Aniline on reaction with concentrated HNO3. Aniline on reaction with concentrated HNO3 and concentrate H2SO4 means reaction with nitrating mixture. Here these two types of products are possible. One is orthonitroaniline and para-nitroaniline. This is the para position, this one is ortho position. For example, if you can take toluene, CH3 plus HNO3 and H2SO4. Here also you can get two types of products. One is CH3NO2 orthonitrotoluene and para-nitrotoluene. Para-nitrotoluene. Because of here NH2 group and CH3 group, these two groups are NH2 and CH3 groups are electron donating groups. These electron donating groups donates electrons towards benzene ring and increase the electron density on benzene ring at ortho and para positions. That's why the second electrophile enters at ortho and para positions. That's why we are getting two types of products. One is ortho and one is para para substituted products. For example, if you can take NO2 group, For example, here nitrobenzene is there. Nitrobenzene plus this nitrobenzene again same reacts with HNO3 and H2SO4. Concentrate HNO3 and concentrate H2SO4. But here you will get what is this NO2 and NO2. Only meta position meta dinitrobenzene. Meta dinitrobenzene. Because of here this NO2 group is the electron withdrawing group. This electron withdrawing groups decreases the electron density and ortho and para positions. That's why the second electrophile enters at meta position. Orientation means in the benzene ring is all if the benzene ring is already having a one substituent, the second substituent position is decided by the, for example, if benzene is having one substituent, this substituent decided the entering electrophile occupies the ortho, para or meta position on benzene ring. Electron donating groups activate the benzene ring means activating groups ortho para directing groups. Electron withdrawing groups deactivate the benzene ring. These are meta directing groups. Thank you.